All right. Good morning, everyone. My name is Scott Grizzard from the University of South Florida. It's Monday, and everything that implies, of course, everything is going wrong. But we seem to be up, so let's go with it. How's everyone else doing today? As usual, there is chat in Twitch. There is chat in Blackboard Collaborate Ultra. My hair needs combing, and typical day. Okay, so let's talk about quiz 10A. Let's see if this works now. Yes, and forgive the fact that there's a little discoloration from the green screen going on. It's Monday. All right, so I want to state the extreme value theorem. Now, they all have similar names, and it's easy to confuse which one is which. For me, I do little drawings to help me remember. So for the extreme value theorem, I usually do a drawing that looks like this. So I've got an A, I've got a B, and I've got something like the oops. And I've got something that's just not going to stop happening, is it? So I've got something that looks like this, right, with a kink in it to remind me, and then I've got like a B, and then I've got like a couple bad ones that I just keep in mind. Something discontinuous there with something like this and something like this. So I have kind of a good drawing and a bad drawing. Okay, this is how I kind of remember them. And so what I do is that I go, okay, so I have this idea of good and I have this idea of bad. And then so I say, okay, then and then all of the preambles are about the same. So I say, okay, let D be an interval, F defined on D. Now, you could use A, B, you can use all of those things. That's perfectly fine. If you like A, B, that's, perfectly good. Now, if F is continuous on D, and D is a closed interval, then, and I kind of also remember that this is a 2-2, right? I remember also that this is a 2-2. In other words, there are two conditions, two conclusions. There exists an U in, I'm going to even write X-min in D so that F of X-min is a global min, and there exists X max in D so that F of X max is a global max. Okay. So I can do that. How do we feel about that? 1 to 5. Just kind of a something like that. So there are other ways to write it. Let's see. So this is question 1. So this is EVT. 1, 2, 3, 4, 5. Start. There are other ways to write it. But they all have this kind of thing, right? I can also say let F defined on A, B, and then I can combine the two conditions if I want to. If F is continuous on AB, then there exists U and V in AB so that F of U is the global max and F of V is the global min. That works too. There are a couple different ways to say this, but I like this one better just because it reminds me of the two things that really have to be true, right? The things are that F has to be continuous on the interval and this interval has to be closed. Okay? So for me, that's what works. Now, what works for you is another issue. Both of these answers are correct. There's another statement in the book that is also correct. But for me, it just helps to remember that this is a 2-2. And I've got some place where I've got a minimum and some place where I've got a maximum. Okay. Are there any questions about that? Okay. This one usually has some questions, right? People are confused about which one works and which one doesn't. So I'm kind of suspicious about there not being any questions. If there aren't, I'll move on. Okay. It's Monday. People just aren't up for Monday. Yeah, I had one of those weekends too, right? I had a long to-do list of stuff that had to get done, and I got none of it done. Right? My brain was just like, no, you worked last Saturday. You're not working this Saturday. Right? Go to sleep. Okay. So I got nothing done either. I still haven't posted the quiz for tomorrow for discrete math at all. I haven't written it yet. Last year's quiz doesn't work, so I have to do a new one. All right. It's Fermat's stationary point theorem. All right. So I'm going to say the exact same thing as I did before. Let D be an interval F defined on D. Okay. If F is differentiable, and then A and D. All right, so this one has another little thing. F is differentiable. And I hate this X equals stuff, but the book does it and everybody else wants to do it. So F is differentiable at the X value A, right? A is part of D, right? So I've already said that. I don't need to say X equals D. I just say F is differentiable at A. But they all want to write X equals A. Okay, fine. And if F has a local min or local max at X equals A, then F prime of A equals 0. 1 to 5, how do we feel about that little definition? So this is Fermat. Oops, nope, no, I don't want to do that. Stop. There we go. So this is Fermat's statement. Sometimes you'll just see this, like on the test, it's likely going to show up as just Fermat's theorem. Because I seem to be the only one who emphasizes the fact that this is the stationary point theorem. The reason why I do that is because there's this whole bunch of Fermat's theorems out there, right? There's Fermat's little theorem, there's Fermat's last theorem, which Fermat never proved, or at least most people don't think he ever proved. There's Fermat's, and this is another one. There's Fermat's principle, which is a thing in physics, and there's this theorem, right? So the book just calls it Fermat's theorem, and that drives me nuts because there's so many Fermat's theorems. So I think that's deceptive. What the... Okay. So that's just kind of the idea. Any other questions? All right. Let's move on then. This definition, I hate this definition, but it's in the book, and Web of Science keeps asking for it, and it shows up on the test, right? It's a critical number. Well, what does that mean? Okay. What's the definition of a critical number? Well, let D be an interval, F defined on D, math is case sensitive, A and D, right? F has a critical number. A is a critical number, not has a. A is a critical number for F if, and then the two things are F prime of A equals 0, or F prime of A does not exist. All right, 1 to 5. How do we feel about that sucker? So let's do the stop thing. That's stop. Critical number. You see this as different things. Critical value. And nobody outside of Calc 1, nobody cares about this definition, right? It has a critical number. Okay, fine. What's critical about it? Oh, those two things. You could have done, right, x is a critical number if f prime of x equals 0, or f prime of x does not exist. You could actually even say if it, right, you could even say something like alternative f has a critical number at x if f prime of x equals 0, or f prime of x d and e. But it's important to remember that this is a particular x. It's not like a general x, right? So, right, it's sometimes easier if you just remember this. F has a critical number. A is a critical number. F has a critical number at x equals a. Same thing. Okay. Oh, by the way, I would remember that this is a 3-1. I'm sorry, a 2-1 definition. Walls is a 3-1 statement. Okay. So for me to remember this, I usually do a drawing that looks like this. So I've got some A, I've got some B, I've got something that looks like this. I don't really care. Right. And I've got, like, here is the U. There's the flat. And there's the equals, right? F of A equals F of B. Right. And then I have a bad, right? I have a bad where I've got this. So I've got this, and then I've got like a bad. Not differentiable. And then I've got another bad. Something like this. Right? We're not at endpoints. Right, and these are just kind of my little sketches. You couldn't see the last one there. Sorry about that. So that's what I do. I have like bad. I have kind of a good in my head, and then I have a bad and a bad. And I remember that this is a 3-1. Okay, so there's 3 conditions and 1 conclusion. So I've got, okay, let F defined on AB. Okay, if f is continuous on a, b, f is differentiable on the open, f of a equals f of b, then there exists u in a b so that f prime of u equals 0. All right. So 1 to 5, how do we feel about that? Now this is rolls. S, stop, and start. Are there any questions about that? That's f of a equals f of b. So the important thing here is that this thing, right, I have to have them equal. The idea is that there's some place where f prime of a is going to be 0. And that's guaranteed because I've got to, basically it says that if I go up, I have to come down. If I'm at the same level, basically it says what goes up must come down and what goes down must come up, right? So if I've got f of a equals f of b, that means if I had a ball and I threw it up, it was at 3 feet, and I threw it up into the air, and then it came back down and I caught it at 3 feet. At some point, the derivative had to be 0. At some point, it had a max or a min. And that's actually an even better thought about this, right? If f is continuous and f of a equals f of b, that at some point I have a max and some point I have a min. It could be the whole place, but there's some point where f prime of x equals 0. And I could even say a little bit more if I wanted to generalize it a little bit. Okay. All right. All right, find the global max and global minimum of f on 1,7. Okay, so what I'm going to do is I'm going to make a list of interesting things, right? So I've got this kind of x's to check, or my critical values. All right, and now I've got the endpoints. 1 and 7. Now I need my critical numbers, right? F prime of x, DNE, nowhere except the endpoints, because f is a polynomial. Right, so f is differentiable everywhere except the endpoint, so I don't add anything when I do my critical numbers. All right, so what I'm going to do is I'm going to go ahead and I'm going to take the derivative here. So f prime of x equals, well, let's see, d over dx of 1/6 x cubed minus d over dx of x squared equals, okay, so this is going to become 1, oh, that's going to be a nasty number, right? So this is going to become 3/6. No, it's going to become a nice number, 1/2. So this is going to become 3 times 1/6 x to the 2 minus 2x. Nice, easy thing. And this is going to become a 1/2. So this is going to become an x squared over 2 minus 2x. Your result may vary slightly based on the simplification that you did. Yeah, I mean, this would be 6 to the negative 1, but you know, you can do that, but there's no, okay, it's 6 to the negative 1. This is really a 1/6, right? Yes, it's a 6 to the negative 1, but that doesn't really help me. Like, x to the negative 1 really helps me. 6 to the negative 1 doesn't. It's really a 1/6 being multiplied through, right? Because 6 to the negative 1 is just a constant, so it's not like I'm going to be doing product rule or whatever. And if you do that, you wind up with 2 to the negative 1 anyway. But that's kind of okay. And so we want f prime of x equals 0 implies that 0 equals 1/2 x squared minus 2x, which equals, I'm going to factor out an x, and I get x times 1/2 x minus 2. Okay, that's glorious. So I pull out the 1/2, and I wind up with 1/2 x times x minus 4. So x equals 0 or x equals 4. And you didn't have, once you got to this, you didn't have to actually factor it all the way. You could have said, oh, 1/2 x minus 2, that's x minus 4. I mean, that's x equals 4 will give me that. I didn't actually have to factor out the 1/2 if I didn't want to. This is kind of a canonical version, but it doesn't really matter. As long as you get the x equals 4. Okay, so now I've got critical values, and then I've got this place where f prime of x equals 0 if x equals 0 or x equals 4. And then notice that 0 is outside. So what I'm left with is check. So my list of x values to check are 1, 4, and 7. Okay. So now I'm going to rewrite f of x so I don't accidentally use f prime of x. I'm going to write f of x equals x cubed over 6 minus x squared here, right? So now I'm going to write f of 1 equals 1/6 minus 1 equals negative 5 over 6. F of 4, oh, that's unpleasant, isn't it? 4 cubed over 6 minus 4 squared. I'm going to factor out the 4 squared, and I'm going to get 4 squared times 4 over 6 minus 1. At this point, I would have, if I was on a test, I would have thrown this in my calculator by now, right? So this is really 2/3 minus 1, so that's going to be a 1/3. I wind up with 4 squared times 1 over 3, which equals 16 over 3. And I want to compare this here to this maybe. So bear in mind that I might want to do a decimal expansion of this anyway, because what I want is the one that's biggest and the one that's smallest. All right, and then the other one I need is f of 7, which is also unpleasant. That's going to be 7 cubed over 6 minus 7 squared, which equals, I'm going to go ahead and factor out the 7 squared here. So I get 7 squared times the quantity 7 over 6 minus 1, which equals 7 squared times 1 over 6. So 7 squared over 6. And I'm going to leave that like it is. Where do you get negative 16 over cubed? Yes, you are right. Because this is 4 squared minus 1. This should be negative 1/3. You are correct. That should be negative 16 over cubed. Thank you. So negative 16 over 3 or over 6? Right. Okay. You're right. I'm wrong. This is what I get for not doing it with my calculator. All right. So now I'm just going to compare which one of these are bigger. Well, this is the only one that's positive, right? So the max, the global max is 7 squared over 6 at x equals 7. The global min is, okay, so this one is negative 16 over 3. This one's negative 5 over 6. Negative 16 over 3 is negative, hello brain, 32 over 6. So this one here is smaller than that one. Right, I multiplied that by 2. Yes, yes. Global min is negative 30, negative 16 over 3. At x equals 4. All right. So 1 to 5, how do we feel about that one? Now, what is this? Question 5. Now that I did the math correctly. And notice here, just like on these related rates problems, I just kind of said what I meant. So the key points to this one are watch out. So kind of gotchas here, watch outs. So watch out, make sure your x is in your domain. And what's the other thing? Use your calculator. Right, because you really do want the decimal expansions. You want to be able to compare these things. Retakes, I'm so far behind on retakes. I need to get them up, and I just haven't had the chance yet. So as soon as I can get it up, I've got to do a whole bunch of stuff first on the other stuff. That's a good question. Okay. So of the 36 of you, 16 have not voted as to the difficulty of this section. Are you guys not watching, or are you just, apathetic, or you don't want to share what you're doing? Okay. I really do want to know how you feel about these problems. It does. Okay. All right. Okay, so I'm going to stop streaming here on thing, and let's talk about the problem set.